So as you look at the HR diagram, looking at how temperature and radius and luminosity is related to each other, of course, the luminosity is simply how much power or energy is being emitted from a star relative to the energy output of our own sun. And the more luminous it is, the greater the intrinsic magnitude of it is. So those two are related to each other, the absolute magnitude and the luminosity. And as we have shown, the temperature and the spectral class are related. And the luminosity and the luminosity scale is shown with this HR diagram. You can see that along the main sequence, the cooler stars, the smaller stars, have, of course, a smaller radius. And as you transcend up the main sequence to the hot ones, the radius gets larger and larger and larger. However, once things start moving from the main sequence and transcending to the giant and the supergiant branch, they get larger and larger. They become cooler and cooler. Their surface areas expand and get greater and greater, and the radius increases in that direction. And Part B also to be aware of the distance modulus and the inverse square law. Now, the distance modulus is probably the most important equation for determining distances in the universe. M is the absolute magnitude. That's the absolute magnitude that's on the axis of the HR diagram, is equal to the apparent magnitude. And you know the apparent magnitude just by looking. You can determine the absolute magnitude if you plot and look at its spectra and then know where it exists on the HR diagram. You can determine its absolute magnitude. And that is, so that is equal to its apparent magnitude minus 5 log 10 times the distance over 10. So if you know any two of those three variables, you can determine the other one. In this instance, R is distance, and you can use it to calculate how far away an object is. The inverse square law, luminosity or absolute magnitude, brightness, whatever, is equal to 1 over R squared, just basically states that luminosity is inversely proportional to the square of the distance between two objects. Here is an example of an HR diagram showing a plot of a lot of different stars on it. It has the supergiant red dwarfs all colored in red. All of those stars are red or reddish, but some of them are very, very cool and some of them are really, really hot. So color alone is not an indicator without other physical data also. I like this particular HI diagram also, particularly this year, because right there is Zeta Orpheus, the little runaway star out there all by itself. You can see it is still a main sequence star, but it's a very, very, very massive main sequence star, and therefore should start its evolutionary sequence fairly soon. Be knowledgeable about Planck's law and Wien's law. Planck's law simply states that a hotter star will emit radiation, more radiation at every single wavelength than a cooler star. You do not see on these three lines that this graph shows the hottest star. Nowhere does the radiation go below the next coolest star. And the star in the middle, nowhere does its radiation output, nowhere is it less than, go beneath the curve produced by the coolest star. So at every wavelength, the hotter star emits more radiation than a cooler star. And Wien's law simply states that the radiation emitted by any star has one maximum wavelength at which it produces more radiation than any other wavelength. And that maximum wavelength is equal to 2.9 times 10 to the 7 divided by its temperature. So the resources for this year's competition is the National Audubon Society's Night Sky. There is a lot of stellar information on the general information, background information on the Astronomy Coaches Manual available from the National Science Olympiad website. apod.nasa.gov is a great place to search for images, any of the deep sky objects. If you plug those in, up will come all of the most important images taken of that particular object over time. The Chandra website for the webinar, of course, and for X-ray images, and Hubble for optical and some UV. The National Radio Observatory has some great material and information on its website and a great photo gallery. Spitzer, of course, has the Cool Cosmos is a great activity on that particular website and great images. And the AAVSO website, if you go to variable stars, down to educational materials, over to Science Olympiad, there will be a 2016 section where this PowerPoint will be posted. And also posted there is the 2013 event on stellar evolution that you might like to download and use as a practice event. The National Event Supervisor for Reach for the Stars is Dusty Schroeder. Here is his email address. However, if you have any question that's really a clarification question about the event description itself or the deep sky objects, you need to go to the National Science Olympiad website and go to the rules clarification section, because if you have a question, maybe something was written a little bit ambiguously, and maybe other people have that same question. So if you post it on there and they give an answer, and then someone else has that same question, they can go and see if it's already been asked and answered, and it saves an awful lot of excessive emailing, as you can imagine, with all the events for both B and C divisions of the national website. And event supervisors are not allowed to answer questions because what if we say something slightly different to one team than we do to someone else? That's not fair to either team or to anybody else. So we are not allowed to ask those kinds of questions. So to prepare for this event, you should read the event description first that we've gone over for the content. Make sure you bring only the resources you're allowed to bring. Use this webinar and the PowerPoint. And the PowerPoint slide set that's posted on the AAVSO website, in the notes section for each one of those slides, for each one of the deep sky objects, I have 1 or 2 or 3 URLs on there that I thought would be kind of the best place for you to go to get together information for that particular deep sky object. And so that should be helpful, I hope. Use the Astronomy Coaches Manual for background information if you need anything on that. And use the websites and the event description that I've listed to you on the previous slide. Don't go anywhere else and rummage around. Really, everything you need to know is contained within those websites that have been provided for you to look at. And you should definitely go to the AAVSO website to download the 2013 Reach for the Stars event, because you can use that as a practice. It has different kinds of star charts. Dusty's quite tricky in finding different and assorted and sundry star charts to use. So that would be useful. And he also we are also going to put together some sample state, regional, invitational events that event supervisors or state directors will be able to acquire and download for event supervisors to use also, to help make up your own, or maybe use one that we'll provide for you. So good luck preparing for this competition, and I hope to see you at Nationals.